Good morning. Get up, everybody. I'll just start in a minute.
Good morning, ma'am.
Good morning. Another just 4 classes I get. Okay, listen. I only for 4 classes. I get actually 4. If possible, I will take extra 1. And I've done till second normal form. Okay. Pre-class video today. I have uploaded a pre-class video. See to that your 4th normal form I've already uploaded. After today's class, you please go through the 4th normal form pre-class video. If any problem, any doubts, you can clarify. In the same way, in the next class also, I'll put one more pre-class video, that is a 5th normal form. Where I felt you don't need much interaction because we have a problems to be solved. Minimum 4 classes we need problems, and both Fridays, this Friday and next Friday, we should see if possible I'll handle. Otherwise, even next Friday I'll not be able to handle. So just that's why I'm yeah. So that's why I'm just trying to put a pre-class video, the topics which you can actually go through that because the topics which I'm doing in class actually is required for the problems. The topics which is not required for the further problems, I have putting it for as a pre-class video. Mostly for next 3 classes, I'll put the pre-class video. Go through that. If any doubt, you should ask me. Okay. It's not that the pre-class video topics are not important, Anta. It's important, but only that the concept is not carried out for the problems such thing. So that's why I'm just putting into the pre-class video. Instead of taking more and more extra classes, I've just put into the pre-class video. So whenever you're in your convenience, you can actually go through that. Fine. Let me start. I think we have done till 2NF, right? Right? We completed 2NF, right?
Yes, ma'am.
Okay. Now we will go to third normal form. So I think by doing 2NF, I think you have little bit understood how actually we will divide and what is functional dependency. Fine. So hope here and onwards you will really understand little fast. If you have any doubt, you can pause me in between. Okay. It's a third normal form. Okay. Third normal. Can anyone tell me based on what second normal form was defined? Second normal form. Yes, correct, Tarun. So why you're not giving answers? You're searching the answers. See, first normal form should be atomic attribute. First normal form. Second normal form should be fully functional dependency, right? So that means atomic attribute should be there. And always in second normal form, it should be fully functional dependency. That means in a right hand side attribute should be completely dependent on the primary key of any relation R. Okay. If it is not actually dependent on the primary key, then it should be divided. Okay, decomposed. Now, third normal form is actually based on the concept of transitive dependency. Third normal form. So, what do you mean by transitive dependency? I think you know that. X tends to Y antandre, in between X tends to Z and Z tends to Y actually, then X tends to Y I can write. Correct? No, that's a transitive dependency. So here actually transitive dependency is if there exists a set of attributes set that is neither a candidate key nor a subset of any key and both extends to Z. So Z should not be either a primary key or a candidate key. Then extends to Y actually holds. X must be primary key, but Z should not be primary key or candidate key. Okay, fine. That's a condition here. Example, say it's like this. What is a X here? SSN. So I can actually derive here SSN tends to D number and D number tends to DMGR SSN andre SSN tends to DMGR SSN through transitive dependency. Correct, no? So that means SSN tends to, I think you know what is transitive dependency. That's why I'm not actually telling much. I think in your DMS you have learned transitive dependency, right? Okay, yes or no? It's in a simple example if I tell, if SSN is a friend of D number and D number's friend is DMG or SSN, always there will be a chance that DMG or SSN will become a friend of DMG or SSN. It's like that, right? So it's like that. SSN tends to DMGR SSN is a transitive dependency. SSN tends to directly have given this FD. Why? Because SSN tends to D number and D number tends to functionally determines DMGR SSN. So that's why SSN functionally determines DMGR SSN. Is it clear of transitive dependency? You have to give me a acknowledgement as early as possible so that I can go ahead. Okay, I'll give you one more example. SSN tends to ename is not transitive dependency. Why do you say that? SSN tends to ename is not because in between them, they have directly derived. They're not indirectly derived, indirectly connected. They are directly connected, right? So, okay, how do you say that? Since there is no set of attributes X where SSN tends to X, X tends to ename, we need like this for transitive dependency. As we are not finding X anywhere, I mean a new attribute which is actually interderives ename. So as it is not derived from any of the attribute in between, SSN tends to ename is not a transitive dependency. Is it clear now?
Excuse me, ma'am.
Yeah, tell me.
Ma'am, X tends to Z and Z tends to Y means this tends to actually means what, ma'am?
Functionally determines
Oh,
FD.
fully functional. Okay, okay.
Ah. Functionally determines andre uniquely determines set andre indirectly in a common terms. If I take, if you know uniquely or if you know so closely that person and that person closely knows somebody else, obviously you will be interconnected to that y person, right? So always
Yeah.
this dependency holds.
Okay, thank you.
Tends to is FD. This arrow mark is FD, functionally determines.
Ma'am,
Tell me.
you told like there is Z tends to Y, no, ma'am. Actually, Z uniquely identifies Y, but you told it should not be primary key
No.
or
I've combined here. Emp department I've combined. See the underline where it is. Here my primary key is SSN only. There is no candidate key, another candidate key.
no, ma'am. For the first example,
Huh?
assistant tends to DM
Correct.
D
Understood.
manager assistant.
D number is not a primary key.
But it can be candidate key, no, ma'am?
But they have not mentioned, no, they've just giving you an example.
Okay, ma'am.
It's just an example. They've combined two tables and they've made SSN as a primary key. So based on an existing relation, you have to derive. So currently what they've given, see, I think you can see an underline here for SSN. For SSN, it has been underlined. For D number, underline is not there. So that means SSN is a primary key. D number is not a candidate key. Otherwise, they will specify it is a candidate key. They will specify. They will specify like this. It is a candidate key. Okay, so here D number is not, we have assumed it is not. So when I solve the problems, you will come to know. Okay, because for you to give instead of keep giving a new tables, they've just given only one schema which you're quite familiar throughout this what I can say, a book. So they combine D number and employee table, assuming we have already told in informal guidelines that when you combine two tables, it is really we are getting a redundant data. So we know that it is a bad relation. So they are coming up with a bad relation and then they're deriving how you can decompose on them. Fine. Any other doubt? Fine. So you understood what is transitive dependency. Here we have still not got the definition of third normal form. Third normal form is based on the transitive dependency. Second normal form is based on fully functional dependency. Okay. Now, what is the third normal form? Very simple. There should not be a transitive dependency. Ashte. Definition of third normal form. According to who has done third normal form? Codd. Original definition. A relational schema R is in 3NF. If it is in 2NF, it should be in 2NF. Okay, then only you can dissolve, decompose, or solve, normalize the table to a third normal form. If it is in 2NF and no non-prime attribute A in R is transitively dependent on the primary key of R, on the primary key. Is that clear? So it's like this. Y tends to A. So they say no non-prime attribute. What is a non-prime attribute? A. So now what it can be extends to A, which is a transitive dependency. No non-prime attribute. Non-prime antandre, which is not a combination of candidate key. No non-prime attribute. Okay, non-prime attribute A in R and the relation schema is transitively dependent on the primary key, which is a primary key, X is a primary key. Is it clear? If it is a prime attribute, then it is not a problem. If it is a prime attribute, it is not a problem. So that's why they say no non-prime attribute should be in R is transitively dependent on the primary key. Okay, so fine. That's a definition. This is actually original definition. And then we have to normalize into 3NF. Let's see here. Yeah, see here they've given an example. In X tends to Y and Y tends to Z with X is a primary key. Yeah, you know that. We consider this a problem only if Yavaga Y is not a candidate key. When do you consider this is a problem? Even though if it is a transitive dependency extends to A holds, Yavaga, either Y should not be a, sorry, Y should be a candidate key. If Y is a candidate key, then obviously we will not have any problem. So when Y is a candidate key, there is no problem with the transitive dependency. So that's why. Okay. No, sorry. That's why we will go into the, fine, no, fine. Based on this, we will let us solve this, then we will go to the generalize. So now this is an example we have already seen that D number is neither a candidate key, right? It's not a candidate key. So, and here is no non-prime attribute. This is a non-prime attribute. DMGR is a non-prime attribute. This is only a prime attribute. No non-prime attribute. No non-prime attribute in R should be transitively dependent on the, okay, there is some problem here. It should be without arrow. Okay, transitively dependent on the primary key of R. So that means it is dependent. So that means this table is not in third normal form. How do you normalize that? It's nothing but this FD. This is one FD and this is one FD. I need to break this FD. Fine. When I break this FD, how I will get? So let me make it as an employee. That is E name, SSN, birth date, address, D number will be here. And SSN is a primary key. What is my new table? Department table. What will be the primary key? D number is a primary key. D name, D MGR SSN. So my two tables will be like this. Okay, check it here. So I have ED1 and ED2. So this is my two different tables now. That is employee department 1 and employee department 2. They have written it as. Is it clear? Now, you have to remember one thing. When you have divided two tables, when you join these two tables, the data should be equivalent to this table. There should not be any loss of data and there should not be any addition of the data. Okay, that is very important. So that's why how you will do whenever you divide it, whichever the primary key you will make it, that primary key as a foreign key you should leave in a previous table. That's one, I can say, a logic or a hint or an idea. I'm giving tips, I'm giving you what need to be remembered. Okay, whichever you're breaking as a primary key, pull that as a primary key. That the same attribute you leave there because that will act as a foreign key. Because when you join, that is the attribute which joins you properly and bring back to the original table. Okay, the data should not be lost. In this, only that the redundancy will be high and null values will be high. In order to avoid that redundancy, I am breaking that so that I should not lose any data here with the original table when I join it back. So that's a note, he says. A natural join or any join operation on ED1 and ED2 will recover the original relation employee department without generating spurious tuples. Okay. Hope this is clear. Don't worry, we have n number of problems based on this to solve. When we'll be solving, everything will be clear. But what is current problem? Have you understood what I've done? Yes or no? Still you are people in a sleeping mode? Very less are replying to me. Very less people. Okay. Okay. Fine, I'll go ahead now. Fine. Fine, I'll go ahead. Now, slightly I will change. There's a general definition of third normal form. There's a general definition for second normal form also. There is no much difference with those two normal form. So any definitions you can write. They say that there should not be a fully functional dependency. Sorry, there should be a fully functional dependency, they say second normal form on the primary key of R. But in the general definition of second normal form, they say there should not be a partial dependency. There should not be a partial functional dependency. Both are same. But there is a small change in the definition of original definition of third normal form and general definition of third normal form. Uh, let's see a general definition. So it will be better always, instead of keeping the original definition of to solve the problem, you remember this one, which is very easy to solve and remember also. What they're saying, the relation schema R is in third normal form if whenever a non-trivial ಅಂದ್ರೆ ಏನು, not satisfying or not important functional dependency which is not actually satisfying third normal form. Okay, non-trivial functional dependence extends to A I have. Okay, if you see that this is a functional dependency which is actually irrelevant to 3NF or which is not important, neither, then you just have to check that either X is a super key, either your left hand side should be a super key or your A should be a prime attribute of R. Either one should be there. Okay, the same thing will be is told in original definition also. Okay, but most of the time you forget this extra definition that in between that should be in between attribute should be candidate key and prime attribute anta. You will only remember transitive dependency. So by remembering only that definition you can't solve the problem. So that's why it's better for you to remember this definition. Any definition you can write for the internals. For problem solving, it is better you remember this definition. For any functional dependency, non-trivial functional dependency, to check whether it is a third normal form, either X should be a super key of R or A should be a prime attribute. Okay. X tends to Y and Y tends to Z. X tends to Z. Right? For each functional dependency, this is my transitive dependency. This is my functional dependency. For every functional dependency, either X should be a primary key or super key. Super key is nothing but a primary key and candidate key. Key. Y should be a prime attribute. Fine. Even this one, this is primary key. We know that. In this case, if Y is a super key, yeah, it's fine. Then there is no problem leaving that. This can be in this functional dependency can be stayed in a table or in a existing relation schema. Or such should be a prime attribute. Andre prime attribute andre ಏನು the attribute which is actually combined with the primary key or any key attribute, super key or candidate key, then that is called as a prime attribute. If any one is satisfying, then I don't have any problem with such kind of a transitive dependency or such kind of a functional dependency. Fine. Done. Shall we go to BCNF? Once we finish a BCNF, we will solve a problem where we come from the first normal form till BCNF, okay? BCNF is also very easy. That is nothing but what is BCNF? Boyce-Codd normal form, BCNF. This allows BCNF third normal form is nothing very simple. It is the same definition, only this B is not there. That is A is a prime attribute is not there. What happened, Andre? In many of the cases, what happened is, many of the cases, you will see which case is that. Many of the cases, they actually found a problem uh, where keeping A as a prime attribute was having a major problem. So with so many examples, they have explained it, but let us not go in depth. We will just keep that on overview. That's enough. So as they could see that, they felt that, who felt? Codd. Codd is the one who has actually done the third normal form. Codd felt that I can make this schema still more less redundancy. Than the third normal form. See, every normal form, that is one normal form till BCNF, one normal form, two normal form, third normal form is everything step by step they are reducing the redundancy and null values, whichever anomalies. All this is reducing only. Step by step I'm reducing. 1NF, 2NF is more strong than 1NF, 3NF is more strong than or stringent than second NF. Now, with the third normal form, BCNF came into. They have not made it as a fourth normal form because it is not a complete different definition. BCNF is a slight change of third normal form. That's why they gave a name of BCNF. I have 4NF, which I've given you in a pre-class video. Please go through that. And 5NF. Okay. 4NF and 5NF, usually it is very rare to arise that. So most of the real world, Ali, your problems will get solved only till BCNF. Okay. So BCNF is a slightly changed concept in third normal form. That's why they've not given a new normal form definition as a 4NF. Okay. It's a Boyce-Codd normal form. That is 3.5. I can say 3.5 normal form. After third, a small change with the third. What is a small change? That's nothing but That's nothing but this is a small change. This B is not there in the definition. Only the first A option is actually there. That is X is a super key. Let's check that. Boyce-Codd normal form. It's the same definition. Check here. A relation scheme R is in Boyce-Codd normal form. If whenever NFD extends to A holds in R, then X is a super key of R. Only this is there. That's all. Definition is done here. Okay, this is a definition of BCNF. X is a super key of R. A is a prime attribute, is not there. Okay, so each normal form is strictly stronger than the previous one. Yeah, I have already told you that. Every 2NF relation is in 1NF. Every 3NF relation is in 2NF. Every BCNF relation must be in 3NF. There exists relation that are in three. There are many relation, I mean not many, very few relation where it says most of the cases when you say X is a super key of R in third normal form, if that satisfies, then obviously 3NF will be in BCNF only. If 3NF is satisfied based on the second example, second option, what is that? A is a prime attribute, then that will be violating a BCNF, then you have to come to BCNF and then solve it. Your understanding? The goal is to have each relation in BCNF. So let's have an example now. Okay, special case, we will just check later. Um, we'll go with an example. I think you will understand later that. Okay. Okay, you're able to see this now. You're able to see this example. Yes or no?
Yes, ma'am.
Yes, I have displayed one note.
Yes, ma'am, it's visible.
I think many of you have lost. I think we will be able to do this. Let's see. Okay, so read the example. This is an example. Let's check here. They have given a candidate key also here. Just the description of the primary key and candidate key I've given there. Not necessary every time they will give you the description because it was in a textbook, I just pulled it. But in exams or a question paper, they will not give you a candidate key or a primary key. Why? Based on what? You just have to analyze. If they've given, you just have to go ahead with that scenario. That's all. This is actually details of what I can say. And again, the America, because the author is from that place. So US or foreign country scenario it is, because county name is a small area, district I can say it. So based on the district name, the what I can say, um, what I can say, a lot number. A lot is just nothing but maybe a property number, I can say, um, or chit lot numbers is actually is based on the district. Property ID I will have, where the complete property ID is for throughout across the districts. It's unique across the districts. Fine. So county name, lot number is actually unique with a district, which district and the lot number, any state or in any state or in a state, any district you can able to identify when that is a primary key. So there's a two. So property ID they've made as a primary key because it was single attribute. So candidate key also they have given here. Okay, there's two things we have. We need to solve this. We need to solve this. Let's solve this till, I think we will solve this till how much ever we can. Okay, from 1NF we will start. So what is a 1NF definition? Atomic. So we assume, because they have not given any what I can say, a definition that the attribute is multi-valued or composite. No such definition they have given. When they have not given any such definition, then we will assume it is an atomic attribute. We will assume it is an atomic attribute. Is that clear? Fine. So what we will assume? It is there in 1NF. Everybody please write down in your book and start solving with me. Satisfies 1NF. Satisfies 1NF. Done. Don't give me any message here because I'm not able to see anything. Currently, I'll not be seeing. So satisfy 1NF. Now, from 1NF, we will check for whether can you able to see, or should I need to expand the image?
I can see, ma'am.
Okay. So now let us just check how many FDs I have. I have 4 FDs, 4 functional dependencies. So can you tell me, out of 4 functional dependency, which functional dependency violates 2NF? Which functional dependency violates 2NF? Then let me check. Yeah, yes, let me check the message. You can put it in a message. Which FD violates 2NF? 2NF is based on what concept? Fully functional dependency. How many? Only one, Tarun? Violates. Tarun is completely wrong. I'm not telling which. Manoj is half and half. Farzana, wrong. Which is not in 2NF. So what is a 2NF definition? It should be fully functional dependent on the primary key. It must be fully functional dependent on the primary key. Tarun, half correct. Nitish, half correct. Okay, fine. Now I could see everybody is including FD2, right? Okay, okay. Let me tell you. When you have a two candidate keys, hold on, don't give me any message now. When you get a two, what I can say, a primary key. So that is a two candidate keys I have, candidate key 1 and candidate key 2. One candidate key is a primary key and one is a candidate key. I'm already telling primary key and candidate key are same. They're same. Only while creating a table, I give it as a primary key because I should take it only one. So now when I have more than one candidate key, fine, when I have more than one candidate key in a table, your FD should be satisfying either one fully. Okay, either one it should be satisfying that too fully. Not necessary primary key and takshna it should be in primary key only and no. See, that's why they have not given it as a primary key here. One they have underlined. That's the first scenario of candidate key. Second, they have given like this. This also is a candidate key. So your non-prime attribute should be fully functional dependent on either of the candidate keys when you have more than one. Now, can you tell me which can be according to my definition? Which is not in 2NF? Correct, correct. So you got my point. Srividya is still wrong. That is correct actually. You need to add one more. Nitish correct and Manoj correct. Correct, Angela. So I think you got it now. So that means check your FD1. Oh, Tarun wrong. Why are you pulling FD2? Chandana correct. So check it here. Your FD1. Okay, fine. Your FD1, it is fully the right hand side, you leave it any number of attributes, it can be any attributes. All the attributes in the right hand side is fully functionally dependent on the primary key. Primary key is only one attribute. So it is actually dependent on that one attribute only. Okay, so that's why it is in 2NF. FD2. When it comes to FD2, all other attributes, remaining attributes, right side attributes, is actually dependent on the fully on the candidate key. See, both attributes of candidate key it is actually determines connected. When both that candidate keys attribute is connected, it is into NF. It is into NF. Fine. Now, check with FD3. Your right side attribute, a non-prime attribute, is that fully functionally dependent on the primary key? I'm telling you, candidate key, primary key, both are same. Fine. Are they fully functional here? No. The candidate key is a combination of two attributes, but it is only dependent on the one attribute or connected to only one attribute, right? So your FD3 is not in 2NF. Now, fine. Now come to FD4. Uh, which one it is checking? Area. Is area is a part of a candidate key? Any of the candidate key? Area? No, right? When it is not at all a part of a candidate key, there will be no concept of fully functional dependency and partial functional dependency. Yes or no? Yes or no? There is no concept of fully or partial. What they have told, there should not be a partial functional dependency. Which is a partial here? FD3 is a partial. Is FD4 is partial? Can you define FD4 as either partial or a fully functional? No, right? Nowhere it belongs. Correct. Nowhere it belongs. Then why do you have to break it? This FD is actually irrelevant for 2NF. This is mute. This is in void. It's nowhere. It is not at all violating because it is not at all in the concept of 2NF. So we are in a void case. We are not doing anything with FD4. Only the FDs which are violating should be the FDs which are violating should be made decomposed. Now, can you tell me which is an FD now? From this FD, it has been normalized to 2NF. So, what is the FD here? Property ID, county name, please write down everybody. Property ID, county name, lot number, area. Which one you have to remove actually? FD3. Another tax rate. Area, area ಆದ್ಮೇಲೆ price. What is a new thing I have to do? County name I have to remove here. I'm not removing, right? I'm telling whenever you do, tax rate is a non-prime attribute actually. You can remove it, right? Tax rate is completely removed. What is an FD I'm following here? So what is my left-hand side is my county name. So then what do you say it as? It should be a primary key. Then what is here county? It is actually a foreign key. Sorry, I should not underline here. County name. Okay. These two is a candidate key. Underlined is my prime attribute. Fine. So here what happens? Usually county name will become a foreign key because combination of county name and lot number is actually a primary key. So aram se in new table you can make it as a county name. So what I will make it as name lots 1, lots 2. Main table name is lots. So let me keep as it is here. Okay. Done? Now. So hope it's clear now. Don't message me now. I can't see the message. Now. I should not now, this given table I have resolved into 2NF now. So what is my current, how many tables I have? 2 tables. These two tables now I have to normalize into 3NF. Because both the tables are in 2NF now. Now I have to normalize into 3NF. Right? What is the definition of 3NF? There should not be any transitive dependency. So that's why it's quite difficult for you to check transitive dependency, identify. So what I'll go with the general definition. What is the general definition of third normal form? Either X should be a super key, right? Or A should be a prime attribute. Now, now check all the FDs whether it is satisfying this definition in a 3NF. Now, can you tell me in lots 1, is there any FD that is violating 3NF? Is there any FD that is violating 3NF? Now you can message me. Okay. Any other answer? Now you have to check in both the table, lots 1 and lots 2. Is there any FD now violating 3NF? Why there is no much answers? Why you people are getting confused? Okay, no problem. I'll tell you. Yes, correct. Chandana. Tarun is correct. Chandana and Tarun is correct. Okay, let me now go back to the writing mode. Okay, see here. Check, come up with, now come up with FD1. Okay, come up with FD1 now. What is X? Property ID. X is a super key? Yes. X is a super key. Okay. So, okay, let me check with FD1 now. Is X is a super key property ID? Yes. So at least one should be satisfying. Yeah, it got satisfied here. So my FD1 is in 3NF. What do you mean? What with respect to FD2? What is an X? X is a combination of county name and lot number, which is a candidate key. Which is a candidate key. So is that a super key? Yes. So one in both with the I mean, I have two conditions to be checked. Out of two conditions, any one should can be executed. So first one is done. Yes. Over. Now. So what is FD2 is also satisfies 3NF. Come to FD3. What is left hand side? X. County name. Is this a primary key here or a super key? Yes. So FD3 also satisfies. Come back to FD4. When you come to FD4, what is the X side? X side is area, Y side or A side is price. X side should be a super key. Is X side is any key here? No. Fine, not a problem. We will check the other side. A should be a prime attribute. Is this a prime attribute? Is this a prime attribute? Which are the prime attributes here? See, county name is a prime attribute. Lot number is a prime attribute. Property ID is a prime attribute. So in lots 2 is also same. County name is a prime attribute. So is price is a prime attribute? No. So that means FD4 is not satisfying both the conditions of 3NF. So which is violating 3NF here? FD4. So now, if FT4 is violating 3NF, then what we need to do? I need to remove FT4. So with an existing lots 1 and lots 2. So my new lots 1, lots 1A, I'll make it as lots 1A. So what I should remove now? Price. Primary key I should keep as it is, because when I combine join back, when are you joining, how, based on what you're joining, primary key and foreign key combination you're joining. So in whichever the table you're dividing, one of the attribute should remain, whichever you're making as a primary key in other attribute, that attribute should be as a foreign key here. So can anyone unmute and tell me what are the attributes I will have? Should I need to keep area or price in this table?
Area, ma'am.
Huh?
Area.
Yeah, who's that?
Nitish, ma'am.
Okay, I need to keep area here because area I am taking into a separate table as a primary key. This is a primary key here, price. Because my function dependencies tells like that area is uniquely determines price, and it is already telling me. So that means I should keep area as a primary key, then area will be a foreign key here. So these two will be a candidate key here. So what is the remaining FD here? Now this will be my FD1, and whenever you're decomposing or breaking the table, two things you should remember. What is the two things? One, FD should not be lost. Okay, you need to preserve the functional dependencies. That's the first one. Next, there should not be lossless or non-additive join. Lossless or non-additive join should not be there. Or no, or there should be, sorry, there should be a lossless or non-additive join. Okay, these two should be maintained whenever you're breaking. My lots 2 will remain as it is. I don't have to break it. I'm just breaking lots 1A and lots 1B. Is that clear? So now let me check. Now let's check with the BCNF here. Now let's check with the BCNF. What is a BCNF? Now I have to check with these three tables. This has been decomposed. So a BCNF is, this is not there. The second one is not there in BCNF. In BCNF, only X should be a super key of R. A prime attribute should not be there. Now check it. What is the X here? FD1 property ID. If X is a super key, yes, correct. FD2 county name and lot number is actually a candidate key. Yes, it is a super key. FD2 is also is in a BCNF. FD3 county name is a super key. X side, yeah, it is in BCNF. FD4 FD4 area is a primary key. It is a super key. Yeah, everything is in a BCNF. Okay. Now let me add one more. Let me add which color? Let me take to lots 1A. Okay, let me first divide it here. So what will be here? Now from lots, it has been divided into what table? Lots 1 and lots 2. So this was in my 1NF, right? While converting into 2NF, this came into picture. Okay. Then what happened? From lots 1, it has been divided into lots 1A and lots 1B when 3NF. It's not so neat, please. Hope you have understood this. Shall I clear this? Shall I clear? Oh, sorry, I'm not able to see the message. Okay. Now, with an existing same, I will just, please ask me if you have any doubt. I'm clearing this. We will solve many problems, don't worry. From next class, we have to solve the problems. Okay. Okay. I'll keep this part. Okay. Keeping this now, area, keeping this FD1 I have, FD2 I have, I will add one more because there is a scenario that where 3NF will not be, because see, in a previous, my complete 3NF was in BCNF, so we didn't go. So many cases it will be like that. But what if you have one more FD? Yeah, this is my FD5. Add FD5. Now check whether the FD5 is in 3NF. Check from 3NF. I think all other is satisfying. All other is satisfying here. 2NF, it doesn't bother for 2NF because my X side is neither fully or partial. It is a non-prime attribute. So it is satisfying 2NF. And come to 3NF. Tell me about 3NF. Uh, what is 3NF? Either X should be a super key or A should be a primary attribute. X is a super key? No. What is A? County name is a prime attribute? Yes. So it is in 3NF. But now check for a BCNF. Is that in a BCNF? Is that in a BCNF? No. Right? X should, it mean BCNF, X must be a super key. X must be a super key. So when X must be a super key, then which one you should divide? FD5 you should divide. Correct? Tarun is asking me some doubt, ma'am. Will lot 1B be decomposed into BCNF? Lot 1B ಏನಿತ್ತು? Lot 1B. No, Lot 1b is this, no, area and price. X should be a super key, it is actually satisfying. This is already in BCNF. There is no problem in lot 1b. Tarun. So now, so the FD5 is not in BCNF. But now think to divide it. Think to divide it. Can you able to break it? If you break, what problem you will arise? Let me see who will tell me. What problem you may arise. Try to divide it. Try to make FD5 and lots 1a separate. See now, when you divide, there is a problem. Okay, let me divide. Let me divide and then tell me what is the problem. Property ID. They know. See, okay, let me divide this first. Okay, let me divide this first. FD5. FD5 yadappa. Now let us not consider this lots 1b. Okay, we are not into picture. We are just discussing the this is an example. We are just discussing this scenario. Let's not take the scenario of lot 1b, okay, because the story will become too lengthy. So now area and county name, right? Area and county name. Area is a primary key. This is my FD5. Correct? No. Now what you will do, see, area is a primary key. So then area should be there in a lots 1a. Then what you should remove? If I keep county name in a lots 1a, it is a duplicate redundant agalva. So I should remove county name. If I remove county name, what will be a problem? According to the rule, all this time we have come across, what will be? It will be like this. If I maintain like this, my FD1 I will have here. What about my FD2? I don't have a scenario for FD2. That means my functional dependency preserving the functional dependency itself is not there. I have lost it. I am not able to preserve the functional dependency because of this problem. Right? Let's discuss the problem. Now you forget about this problem. We will come back to this problem in my next upcoming slide. Now you understood? We will divide it. That's as usual. Now, let's go back now. Usually, when it comes to the BCNF, usually we will face this problem. Okay? Usually we will face this problem. What is a special case problem? See, this is how we have divided. But my FD2 has been lost here. Because there was a fully functionally dependent on both. But again, these two attributes will be, sorry, it will be like this. Is this a candidate key? No, the complete story again changes here, right? Okay, forget it now. So then, what is the problem? We will see the problem now. This is a special case. What is a special case? In practice, most relation schema that are in 3NF are also in, oh my God, it is 10:15. Huh? Is this 10:15 or do I have some time? 2 minutes I have, okay. Let me see the special case here. In practice, most relation schema that are in 3NF are also in BCNF. Only if there extends to A. So extends to A, that is a first condition. If it is holds good in 3NF, then that will be in BCNF. We have already discussed it, right? The relation schema are shown in figure illustrate the general case of such relation. Such an FD leads to potential redundancy of data. Just check it here. This is an example here. See here. This was a scenario of my previous case, FD3 and FD5. Now they've given R. AB tends to C, but C is in turn is dependent on B. If I want to break it, I need to pull, right, C to B. I need to pull C to B, and then I should keep what? A to C. Is this correct? I don't know. I don't know it is correct or not. Fine. Why? Because when I join these two, I should get a back to this. Data should not be lost or addition should not be there. For this problem, breaking, you're not sure how you can break it. For this problem, what we will come across, there is one small algorithm to break down whenever you're finding like this, because your FD, you have lost your FD here, FD1. Yes, correct, Manoj. Candidate key is lost here. So when candidate key is lost here, the complete story of that relation is completely lost. So when the candidate key lost, you need to take care of this step. What is this step? So now the same example, now it is given in this way, a data they've given. So now two FDs, A and FD, same thing it is. Student course tends to instructor, instructor tends to course. Fine. See here, student course, comma course tends to instructor. That is AB tends to instructor and instructor back tends to course. It is the same example of this previous one, this one. See, student course tends to instructor, instructor tends to course. It's the same thing. So now let's see what happens. I have these two functional dependency in. So which is actually similar to that relation 12.112 is my ABC. ABC. It is similar to that. So this relation is in 3NF but not in BCNF. But a relation not in BCNF should be decomposed as to meet this property. What property? What I am actually foregoing my preservation of functional dependency. There is two important rule when I'm decomposing, that I have to preserve my functional dependency. And what is my next one? What is my next one? I myself forgotten. What is my next point? This non-additive join property. I should see to that. I should check with the non-additive join property. Lossless and non-additive should be maintained. As I'm not able to preserve the functional dependencies, it is very much necessary that I have to maintain this property. When I join one, there should be a proper data given, not a loss or not additional data. Three possible decomposition is possible. What are three? Give all possible. See, student instructor, I have to divide it. So your primary key is based on you. Okay, let me come back to this point. Okay, so okay, just divide it. All possible you divide. I'll just write in a shortcut. Okay, student combination instructor, comma, student combination course. So when there is a student, one student can have any number of instructor. So that means it should be combination primary key. One student can have any number of course. That means it is a combination primary key, both the tables. Next combination. Okay, student instructor, student course item. Next, student instructor, student course. Next course, student, course instructor, right? Course, student, course, instructor. Next ಏನಾಗುತ್ತೆ? Instructor, course, instructor, student. All combination I've taken. So primary key, one course can have any number of students. So it is a combination. One course, one student. I can actually make that one instructor. So which one you will make? A primary key. I can make either a course or a instructor a primary key. Okay, making a primary key is not a big question. You can just make it like that. So like this, it has made a primary key here. You can check it here. What is the time? I think I'm going quite fast. 19. Okay, let me end it. I don't think I can end it here. Okay, algorithm we will just check tomorrow. Okay, and then we will start with the problems. Thank you. Next class. Can you tell me when you people are free? If possible, I'll take one extra class. I'll just let you know. I'll check with your class teacher and then let you know.